Hi. So in the previous talk, I showed how to set up Yocto Project and how to build and run an emulator. So just a quick recap, what we did, we added the Pokey folder, we sourced the OE init ben build env script, and we used the first one directory. Now it does not print a lot of other things because we already have a conf directory over here, but at the end of the process we will have all kind of folders where most of the work would be under TMP, and after that the end product that we'll have will be under images for the machine that we built, that is QEMU x86-64, where some of the interesting things, and these are links but they point to files within here, would be the ext4, the root file system. Here we also have like the root file system tard. We have the kernel. This and these are the same. This represents the Git version, the Git revision from which the kernel is taken, and this is the binary itself. And we have the modules here. We could also have RAM disk, we could also have other things. It depends also on the target, on the BSP, depends on all kind of things. So this is what we built, okay? And if we go back, or we don't even need to go back for that, because we built a QEMU machine, and one of the important things that it helps us to set up some things automatically is this configuration files, then we can just go ahead, do run QEMU, no graphic, and at the end of the procedure we'll have a kernel that is running. So I'll get to it in a second. I want to tell you what I want to add to it. I will use the boot time for it. All right. So what I want to add to it is actually the following thing. I want to add a simple C application that we will build that does the following things. If I build it like without much thought, then the result would be like a.out, and I could say run it with one parameter, run it with another parameter, or run it without parameters, just say, hey, stay home, stay safe, and so on. The file itself doesn't say much. I mean, it's just a very, very, very simple application, printing some things to the screen. Now, I built it with GCC, but I could alternatively make a make file. I could use CMake, I could use QMake, I could use autoconf, I could go crazy and use Gradle, I can do a lot of things. Now, what I'm going to show here is the usage of automake. The reason I'm doing it is because my intention is to add this simple application to the Yocto system that we built here, which I'm just telling you that its name was FOSS something. The name of the application will be FOSS something. I do tab here and it does not exist in this image. And my objective will be to add the build of this application automatically to the exact Yocto project that we're building now. So if I go back, let's see what are the steps that would be needed from an autoconf project. So the important files would be configure AC and makefile am, where configure AC tells us all kind of things. You can just take it as is, and this is the name and the version that was put. It doesn't really matter. What matters more, for the sake of our final like binary name or the sources that we need to build, is the makefile am, where the source is coronaoption.c, and the binary name in being programs is FOSS 2020 demo, and for this reason this is the syntax for automake and autoconf. We're going to take the binary name and then append to it underscore sources. If I want to build, my objective will be to do ./configure, but ./configure does not exist here. So the way to do it, there are several ways. The easiest would be to use autoconf -- install, which will generate all kind of missing dependencies. And this is what Yocto Project does when it uses the class autotools. So if I do this, I will see that there will be warning and errors, and I will see that all kind of files will be generated for me. However, there will be an error that say, hey, requires these files. So as a quick workaround, I'm just going to go and touch them. So I'm going to touch news, readme, authors, and change log. I'll do the autoconf again. This time it will work, and then I can do /configure, and you'll see the non-configure output. Of course, the output of it will be okay. Of course, if you know it. If you don't know, then this is what the autotools do. The idea is to generate the make file. A make file that is much longer than just GCCing it, okay? And there are reasons for it. If it interests someone, I can do an autoconf tutorial if it really interests someone. But the important thing is that I can now do make, and the result will be this guy, FOSS 2020 demo, as represented by the make file that I made. Now, Yocto is going to do these things. So there is some sort of like trade-off actually between what I want to do automatically and how I need to put things in configuration management. All right. So for this reason, in the Git repository that I publish, I will put it in the comments in YouTube or in the description. Then there is another branch. So let me just go ahead and clear the files that we added here. Let's look at this. These are the files that were added here. And I'm going to go ahead and do git clean -fd. That is, F is clean, force the cleaning, and D is going to be delete directories recursively as well. So now I have much less files. License has been added because open source projects and open source based software, like the one that Yocto will put on the prospective target device, require licenses for every piece of software. Even if there is like no license, you say, okay, it's proprietary, but you need to specify, okay? And the README file is actually going to tell you how to like use autotools, and going to say a couple of words, a couple of things. And the reason for it is that the branch that we are using now is a branch that has the minimum required things for source control, okay? Now, the autoconf quick fix will have a little bit more, okay? That is the files that I put here. So you can see in the repository, this is what it is. Otherwise, they're pretty much the same, okay? So this is what we're going to build and add to the Yocto project distro that I had here. Now, let's have a look. I remind you, Control A and X is terminating the emulator. Let's have a look at how this guy was defined, okay? So in local.conf, we didn't really change much. I mentioned that there are two important directories, dldir, that is for the downloads, and state cache dir, which is for the state cache. And if I don't build for the first time, I can take advantage of all the packages that have already been fetched and all the Git repositories that already been cloned and all the build steps that have already taken place, including the unpacking, including the packaging, including the building, of course, configuration, and so on. I could just save a lot of time, but not redoing things again. This is one of the things that Yocto Project does very well, and tracks a lot of information of what it has been doing to save time in the future. So if I go ahead and do that, then I I can actually take advantage of existing like a tree. Okay, so here I'm going to go and run again the OE init build env with this directory, which is another pre-built, but I'll show you like how I did it. Like maybe at the end of the video, I wanted to keep the video short. The problem is that I like explaining things, and usually in full classes that I teach, then I explain the rationale behind pretty much everything. I leave no stone unturned. However, I suppose in YouTube videos, then the objective is to be as short as possible. So maybe I'll do like another version of like 5 minutes. I don't know. Okay. So let's have a look what OE init build then does among things. I'm not going to explore it like completely. Okay. What I am going to do is just quickly show you. So it's just a bash script. Okay. It's going to check, although there is a bug in it, to be honest, that it's that you run it, that you source it and not run it, and there are all kind of things like that, and then it's going to run scripts OE build elv internal, and at the end of it, the output directory where you're going to work, where your build will be, is called build dir, and we change directory to it. Okay, this is why when I source it, I will now move to this folder. Okay, all right. So what does it does in between? Quite a lot. It sources this script that does a lot of things. One of the things, by the way, is this guy. There is like the setup of the build dir, and there are like a lot of like printing that are going to be done. And if you see that it's like the first time, then it will say, hey, you did not have a conf over there, and let's do this and that and another. Now, this is the already built version. Let me just show you. Here I run QMU, and I'll show you the final result before I show you like how we build these things. Okay, so QMU will now run. I made a mistake now. I wanted to run it with no graphic, because otherwise it will be so slow. So let me terminate it, and let's run QMU with no graphic. This will be much faster, will take a couple of seconds. And at the end of the process, then we will see that the FOSS 2020 demo executable that we built indeed exists. Okay? So we will also see that, let's say we don't know where it is, although it's very easy to guess. We can go and like use find util. It will be slow, but it will work. It will be slow because this particular instance does not support nested virtualization. So you see that it's in the user bin alongside other tools. So you can see that it exists in user bin alongside other tools. Most of them point to BusyBox. But here, this is not a symbolic link. This is an executable that we built, right? So, how did we do it? So, we did the following things. First of all, this is the output, okay? And every time I want to build something, I need to specify things in the conf directory, which I copied from template that is available for you in the GitHub repository. So let's have a look at the important things here, okay? First thing that is really not important is the template config. So let's just go very quick over it. It says, hey, go to meta-poke-conf, and then you will see all kind of messages that come from there. Taken as is, all right? Then the bb_layers_conf. We will see the exact same thing as in our first one program, but in addition to the meta-poke, meta-Yocto BSP layers, we add another one, meta-pscg. Top dir is not an environment variable that I will see myself. The environment variable is going to be the build, but rather it's going to be one other variable that the bitbake system uses, just like bb layers and bb files and poke bb layers conversion and the likes. So this is what I changed here, and the top dir meta-pscg refers to wherever I did the source OE init build env for, which is this guy, meta-pscg, okay? So this is something that I also copied exactly as is, and I will show you where I copied it from, and then we'll analyze it. So the way I set up it was as follows. Poke_src is my poke directory, and we want to use from it the OE init build env on our destination directory, which in this case is going to be the FOSS 2020 live. Now look what I did before it. I created this directory and I copied to it reference conf and reference meta-psg, which you will see under the GitHub. Okay, so it already has a conf, and once it has a conf, then it's changed directory into it. And in order to build, we're going to use bitbake core image minimal, and in order to run the emulator, we're going to run it. Okay, so I'm now going to get out of like the result this live. I'm going to look at the directory that I actually prepared. They are exactly the same. I did not touch them at all. So the first thing, and this is a very important optimization that will enable me to build very, 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 very fast, is in local.conf I have the following structure. I didn't modify anything here except for two things. DLdir, that I referred to be FOSS 2020 common, and here we have home. We cannot use the tilde sign in local conf. It will not replace well, okay? So we're going to put it under common. DLdir will be this one and download, okay? And the state dir is going to be this one and state cache. Now here I did a trick. What I did here in the common directory, I actually prepared symbolic links to the version that I already built before. That is the first one that has the downloads, and here you can identify your favorite one, okay? And the state cache. Now pay attention, this is after I already built. We see FOSS 2020. This was not on our previous demonstration where we just built an emulator out of Yocto the way it is. So it means that it's a shared directory for all of the builds, not only read-only for the newer build, but if it writes anything, then the other builds also get from it. The other one is the state dir, state cache dir, that this you can identify the pattern for if you have like all kind of if you have experience with Git plumbing, it makes indexing of files easier. Okay, so here you have inside these tarballs and inside these things you have like information on what has been done. So I'm not going to get into it. If it really interests someone, I can analyze it, but I'm going to tell you one thing that is super important. As state cached here is not going to be compatible between different operating system versions. So you need to be very, very careful. Don't think that you can download it like anywhere and everywhere and move it, okay? What you can be confident about is that if you move the downloads folder, then it was going to be okay. So back to our stuff. So we figured out that we cached things in the right way. And actually, what most people do when they start with Yocto, they are going to take this local conf and they're going to add the packages or some features, for example, to enable debuggers or to enable profiling or to enable all kind of like development packages and so on. They're going to just go ahead and add all kind of features in the conf file. Now, this is okay because it's easy, but it is not the organized way, and it will affect actually everything that you build out of this conf file. In a full course, we talk about the different considerations, and also when I help people optimize their Yocto workflow, then usually there are good practices that are worth adhering to. There are always exceptions, but like in 98% of the cases, you can organize things better with layers, which is our next subject. So what I did here is, let me remind you, I added BA layers. In the BB layers, I added top dir meta PSCG. Now, this was exactly this meta PSCG. As you remember, I copied it. And if I look at it, let's see what we have. So first of all, let me just tell you something. For a layer to be Yocto compatibility so that you can submit it upstream and be listed in the yoctoproject.org website, then you need to also provide several files like for maintainers and readme and how to contribute and so on. I did not do it. I just did things as quick as possible. So if you look at the files that we have here that are important, there will be this. Layer.conf is essential. It's going to tell you where, for example, where to find the metadata, where to find the recipes. So in this particular case, let's have a look. We're going to say, okay, we add to the path the layer directory, and bb files, where to search for bb and bb append is going to be here under the current layer, recipes dash whatever slash whatever.bb. This is pattern where I will be looking for metadata, and another one is the second one with a bb append. Okay, bb is a bitbake, and bb append is appending to a current bitbake recipe. bb collection is going to be the name under which I'm going to actually override all kind of properties. For example, the file pattern is going to be everything that like starts with layer dir slash whatever. Priority, if we have like mixtures, like collision between like versions, then it says, okay, what do you take first? Layer version is a versioning, usually it's going to be an integer, and layer series compat is something that I actually added because there was a warning. It's not that critical. However, you want to say, if you just support, for example, the Zeus version, then you want to say, hey, I support Zeus, I do not support Warrior. So you can even give it like future versions that do not exist yet, like Danfo and Gatesgarth, and you can give it things that are not existing. Maybe in the very far future they will make a run version. I think it will be a very good name, but at the time it doesn't make much sense. So this is how we specify how to find the files. The second thing, I skip it deliberately. I'll get to it later. And the third thing, we specified where to find the files, recipes dash whatever, here too. But under this, we add slash whatever, and then slash whatever.bb. So let's have a look at what is happening here. Let me remind you, the objective is to go ahead and build this guy that we'll take from GitHub. Now, where do we take it from? We take it from this URL. Okay? And in addition, we take it from a specific branch that already has the files that autoconf requires. So let's do this and let's have a look at the recipe, okay? So it's going to be very, very, very simple. Why? Because I'm going to inherit autotools. Now, I give it a summary. There's a lot of additional metadata that I can specify. License is always essential, okay? But if I say that, hey, this is like GPL v3, I can actually use predefined licenses in the Poki distro. I did not have to specify the license. I just did it because it's a good practice. Who said that my project will be used exclusively by Yocto Project? Maybe I just want to GCC it and provide a license, okay? So that's like a GPL, and you must, if you change anything, redistribute the source code. srcuri is where I take it from. So pay attention. When I looked at the config, it was https github.com and so on. Now I want to do the same things, but I must specify the provider explicitly. If it's Git, I must specify that it's the Git protocol. Otherwise, it will think that it wants to download a tarball. Okay, this is the default assumption when you want to get something from some URI. This is the default assumption. So what we're going to do is replace HTTPS with it, and then say that the protocol is HTTPS, and we require a particular branch. So we're going to say, hey, this is the branch that we want. So the commit that we had, let's see what it has. So we can see that the particular commit that we stated, the src-rev, it actually added our files, authors and changelog and use and readme, okay? So this is what we specified. This src-uri-md5 sum is actually not necessary when you have a Git provider. We could have deleted it and then it would be perfect. No problem at all. And we say that like the working directory where the source will be unpacked, where we're going to work, is going to be workdir/git. Okay, where workdir is a predefined working directory for the current recipe. Now, this is just like a common practice. You can do whatever you want. Inherit autotools means you have like automatic rules that are used for that. Now, the last thing that I would want to do is actually build the image itself, okay? That is, append the particular package to it. Now, what is the deal here? Let's say that I want to actually build a very particular package, all right? Without yet integrating it into the image. So what I would do would be something like bitbake and then the name of the provider. Now there are rules for it. For example, if I have a file that is called corona-options, then this is the package name, and this is like the package version. So I can go ahead and either give Corona opinions or Corona opinions 1.0 and so on. It's called provides. That is, this recipe provides one of these names. It provides pn, that is the package name. It provides pn pv, package version. There could be a revision and so on. Okay, so I can either do this bitbake and one of the provides, or I could go ahead and use bitbake-b to provide to specify a particular recipe. Okay, so I'm just going to do that if I want like to build alone. It's going to parse all the recipes that there are anyway. Why? Because it needs to find who provides Corona opinions. There could be several ones, and then there will need to be some sort of definition who is who. Okay, so now it already built it. So it says, hey, these are like the tasks that we needed to do, but everything was done. We did not need to run anything. But what we do see here is that we have in the build configuration, as opposed to our original build configuration that we had in the previous example, we have our layer here, and we have the branch and the latest commit that we are using there. How do I know that this is it? Let's have a look. So if we go to the meta psg and we do, for example, git log, we will see that this is it. Okay, master and this commit. Okay, so it's going to be the exact same numbers. Great. So this is a way to build. I can, of course, and you can look at the bitbake manual, do all kind of things like do only particular tasks. For example, do fetching. I can, even if there is no need to do something, I can use the -c in order to redo task. Anyway, it's called invalidate stamp, but I will not do it. I will just tell you that if I do this, but don't find a way, that is, I do like bitbake and the recipe, and don't find a way to specify that it goes into the image, then I will have this built. And I actually do it a lot of times where I just want to like build something from source and use it like on my own computer, not on the target. I do it a lot of times because it resolves dependencies and it's easy for me and all kind of things like that. But it means that it does not run at the target. So I need to attach it to the target some way, somehow. So the trick for this is going to be as follows. I'll go back. It's the exact same thing, but just to have like the same paths. I'm going to go to meta psg, and I told you that we skipped the second one, so now I'm going to look at it. So we're going to go to recipes, core, images, and we're going to look at core image minimal bb append. And here, ignore the comment. It's because I gave some exercises like a phase to understand the build system and not in this talk. Here, look what we do. We have image install and we append to it, space here is very important, Corona opinions. So what I built now with bitbake, like from the command line, I now go and actually add to the final image, and this is how we managed to build it. So this was the demonstration of how to add a recipe to our files, to our distribution. And if you want to understand more about the structure, what are the images, what is core image minimal, you're going to need to look at the POKI, the Yocto Project layers, and search for recipes core images over there. And for example, the core image minimal.bb without a bb append. But this is another subject that, if there is interest, I can cover, and I can cover to a very, very, very great depth, which would take quite a lot of time, probably. So I will put a link in YouTube, but in general, these things appear in GitHub under these things, okay? So this is it. If you happen to watch the video on time, then I'm actually going to deliver a couple of Yocto Project courses in April. And if you need anything, feel free to reach out. And that's it.